I'm going to show you how to work out the density of two liquids combined together or two metals combined to make an alloy. So we will need the density mass volume formula triangle that tells us that density is mass over volume, and we need to know that to find the combined density of two liquids we do need the total mass of the two liquids divided by the total volume of the two liquids. So if we look at this question here, and you can write it down in your notebook if you think it will be useful, we are told that we have 180 grams of copper mixed with 105 grams of zinc to make the alloy. Then we're given the density of copper and the density of zinc. We're not given the volume of copper and volume of zinc. The thing to be really careful of is to understand that we cannot just add up the 9 grams per centimetre cubed and the 7 grams per centimetre cubed, or find the average of the two densities to find the combined density. We must work with the masses and the volumes. So when doing these questions, it's a good idea to create a table with the information that you've got and the information that you need to work out. So in my table, if I have my copper here and I've got my mass down the side, so the mass of copper I'm given is 180 grams, and when working with density and speed and compound measures, I always keep my units in the question to make sure that they are consistent. And then for the zinc, we are told that we have 105 grams. We're then given the density, so let's write that in the next row of the table. So copper is 9 grams per centimetre cubed and zinc is 7 grams per centimetre cubed. What we're not given is the volume of the copper and the zinc, which we're going to need to do total mass divided by total volume. So from our density formula triangle, we know that volume is mass divided by density. So to get the volume of the copper, I want the mass of the copper, which is 180 grams, divided by the density of the copper, which is 9 grams per centimetre cubed. Again, notice I'm putting my units in my calculation to make sure they are consistent. My density is in grams per centimetre cubed and my mass is in grams, so that's good, they're consistent. 180 divided by 9 is 20, and because my density is grams per centimetre cubed, my volume is in centimetre cubed. If we do the same for the zinc, we need to do the mass of the zinc, which is 105 grams, divided by the density of the zinc, which is 7 grams per centimetre cubed. And if we work that out, that gives us a volume of 15 centimetre cubed. So now we have the mass of both the copper and the zinc given in the question. So we can get if I do a final column in my table over here, we can get the totals. So the total mass is 180 plus 105, which gives us 285 grams. Remember, with density, we can't add densities. Let's just write that in there to remind us. Cannot add densities to combine densities. Volumes we can add, so our total volume is 20 plus 15, which gives us 35 centimetre cubed. If you wanted to put some lines on your table so you can see what's happening a bit better, we can put some lines in here. We've got our copper, zinc and total columns, and then we've got a row for mass, a row for density and a row for volume. So now we've got all the information that we need, we can work out the combined density, which is the density of our alloy. So that's going to be the total mass, so the mass of our copper plus the mass of our zinc over the total volume, so that's the volume of the copper plus the volume of the zinc. So if I use the values from my table, I've got 285 grams divided by 35 centimetre cubed. Notice again, I'm keeping my units in my calculation because that's going to tell me that when I do that division, which I'm going to use a calculator for, and I get 8.14, the units of density are grams per centimetre cubed.